Hello everyone, I hope you are doing well. So in this video, I'm going to discuss Leetcode problem of the day, and today's problem is daily temperatures, and it is a medium level problem. So this particular problem is a very simple and good example of a very standard technique which is used in many places, and that technique is called monotonic stack, right? Now, the problem basically says that we have been given a temperatures array and we have to return an array answer such that answer of I is the number of days we have to wait until the next ith day to get a formal temperature. So basically, for each of these values, I have been given a temperature value. I have to find after how many indexes is there a value which is greater than my current value. So for example, if you look at 73, just after one index at this particular position, this value is greater than my current value. Now for example, have a look at 75. If the output is 4 for this particular value, if I go to 4 positions in front of 75, that is 1, 2, 3 and 4. This is the first position at which my temperature or my value is greater than my current value. This is what we have to return. Now, I am going to first explain you how do we actually solve the problem using this particular technique. Then I'll try to explain you why this technique always works. So basically what I've done is I've created a stack of pair of integers, right? Now, what I will do, I will initialize my answer with n or size n and zeros initially. And I'm just going to traverse the whole array in the reverse order. So what I do, while there are elements in my stack and my top element of the stack has a temperature value less than or equals to my current temperature, I'm going to pop it. Now, if my size has some elements and the top value is greater than my temperature value, then I'm going to take its index. So that is why I was storing a pair, because I have to store the temperature value as well as the index. Now I'm going to take the index and subtract I from it. So basically calculating the distance between the two indexes. And at the end, I'm just going to push my current element, that is temperatures of I into my stack. At the end, I'll just return my answer vector. So why is this part always working correctly? Let us try to understand that, right? So let's say we have some elements C here. Now there were several elements in between A, B and C, right? So we have B here, we have C here and we have A here, and there are several elements in between. Let's say we will try to establish the relation that A is greater than B and B is less than C, right? So what we generally do, let's say you do some work till here and let's say you push all of these elements into your element B. Now whenever you come to B, you see that all of these elements that are between B and C are smaller than B, right? That means I want to remove it from the stack, right? So that is exactly what I was doing here. I was removing them from the stack. So how it will actually help us? Let us say that we have C, then we have some element, let's say P, P1, P2, P3, P4, and then we have B, our latest element. So our stack will look something like this, right? So what I will do is I'm going to remove all of these elements, right? So until this part, it must be very clear that we are inserting some elements and we are removing the elements because we want to find an element which is greater than my current value, right? So until I find an element which is greater than my current value, I'm just going to pop all of these elements. Once I find this, I'm just going to set my answer and then insert B like this. Now let's say when I reach A is greater than B, right? So that means A is going to pop B as well, right? But what about these elements that were between B and C, right? So what about these elements? So you will always realize that if A is able to pass B, then A would have passed these elements as well. So basically what is passing? Let us understand that thing here. I am looking for an element X which is greater than my current element. So all the elements Y which are less than or equals to my current element should be passed, right? So B could pass all of these elements because it could remove all of these elements from the stack. Now if I talk about A, if A is greater than B, if A is able to remove B, then definitely all the elements that were removed by B would also be removed by A as well. So that is why I can use B to pop all of these elements in the first place. This is the idea of monotonic stack, and the monotonic stack is always either increasing or decreasing. In this particular case, as we go from bottom to top, let's say CBA, all of these values will be decreasing. A will be the smallest value. So this is the whole idea, that you don't have to worry about A passing over all of these elements. So if we think about the brute force approach, what we generally do is we will just going to traverse this particular whole array, right? This is what we are going to do. But you will see that I know that I want to pass all of these elements, but I have no way of passing it in constant type or just going through over them, right? I know that A is greater than all of these elements, they are anyway going to be discarded and I'm going to reach C, but there is no way of determining it earlier. This B has already popped all of these elements so that A does not have to go through them again in case A is able to pass B, right? So that basically means if A is able to pass B, then it is always going to pass all of these elements which were removed by B, right? So this is the whole idea of the Platonic stack, and now this way it helps us to avoid removing these elements or avoid passing these elements again and again, right? So you can also think it like this. I'm just giving you one more way of thinking it. B is like a gatekeeper to all of these elements. If B is able to remove these elements, B is a gatekeeper of these elements, right? If there is any element that cannot remove B, for that particular element, B is going to be the answer, right? But if it is able to remove B, then it would easily be able to remove all of these elements and nobody can protect them, right? So this is the whole idea of the Platonic stack. It's not very difficult. It's a very simple concept, and here you can see the code is also very simple. You just have to pop all of the top elements until you find an element which is greater than the current element. As soon as you find that particular element, so here whenever this while loop stops, it can be because of two reasons. Either your stack is empty or the top element is greater than the current element. So that is what exactly I am verifying here. If my stack is not empty and my top element is greater than my current element, then I am going to update my answer, right? And as usual, you just have to push the current value into your stack. So this was all about this particular problem. Let me just quickly submit this and show you that this particular code works. So you see, this passes all the test cases and this solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drop, keep coding, stay safe, bye bye.